Hello and welcome to Textbook Engineering Problem. Today we're working out of Elementary Principles of Chemical Processes, 3rd edition. Today we're doing problem 3.10. Limestone, calcium carbonate, particles are stored in 50-liter bags. The void fraction of the particulate matter is 0.30 liter of void space per liter of total volume. And the specific gravity of solid calcium carbonate is 2.93. A. Estimate the bulk density of the bag contents. Kilograms of calcium carbonate per liter of total volume. Okay, so we'll do 3.10. Okay, so the void fraction is equal to 0.3. The specific gravity they gave to us is 2.93, and we know that the space that the salt takes up in the bag is going to be 1 minus the void space, because there's either void or there's salt in the bag. Sorry, when I say salt, I'm referring to calcium carbonate. Okay, so that means that there's 0.7 volume of salt per the total volume of the bag. We know that the density of the salt, this is the bulk density of the bag for part A, is equal to the density of the salt, which is kilograms per meter cubed, multiplied by the volume of the salt in the bag, because this is volume of salt. Okay, so these volumes of salt will cancel out and we'll be left with mass of salt, which is mass of salt per volume of bag. Okay, so we'll be left with kilograms of salt per volume of bag. So that is the volume of, or that's the density in the bag. Okay, let's do part B. Estimate the weight of the filled bags. State what you are neglecting in your estimate. Okay, so the weight of a filled bag is equal to 50, so each bag is 50 liters of volume. So mass equals density times volume. So we've got our density here, which is 251 kilograms of salt per meter cubed, and this is the bag volume, and we need to multiply it by the total bag volume, which is 50 liters. There are 1,000 liters in 1 meter cubed. Okay, so the total mass of the bag is 102.6 kilograms, but it didn't ask for the mass, it asked for the weight of the filled bag. So now we need to calculate what the weight is. And the weight is mass times acceleration, which is the acceleration due to gravity. So we'll do 102.6 kilograms times 9.81 meters per second squared, and that equals 1,006 newtons. However, this calculation assumes that the container, the bag itself, is negligible. The weight of that is negligible. So assumes the container has no weight. Okay, let's do part C. The contents of 3 bags are fed to a ball mill, a device something like a rotating clothes dryer containing steel balls. The tumbling action of the balls crushes the limestone particles and turns them into a powder. The limestone coming out of the mill is put back into the 50-liter bags. Would the limestone, 1, just fill 3 bags, 2, fall short of filling 3 bags, or 3, fill more than 3 bags? Briefly explain your answer. Well, if you're turning this, you're pulverizing this into a powder, theoretically, we're below the maximum packing factor. So the theoretical perfect sphere packing is 0.74048. It's right somewhere right around here. That's like the theoretical packing limit for spheres. So if we imagine that these little tiny particles are spheres, then we could technically pack them tighter than what we've got right now. But here's a couple other considerations to make that also make it seem like we will probably not fill up the 3 bags all the way to where they were before. So that means that the option 2, it will fall short of filling 3 bags, because likely the particles will pack more tightly, because we'll be closer to the theoretical limit of perfectly packing spheres with these really tiny particles that we have. That's one consideration. The other consideration is if you're using a ball mill, they've got just a ton of surface area in them. In the transfer and handling of those bags and putting them into the ball mills and then having all those balls coated with this really fine powder, you're likely going to lose some material. Like, you're not going to be able to recover 100% of all of the salt that you put into that. And so that's another reason why you probably won't fill up the 3 bags to the point that they were as well. So those are 2 reasons why you may not fill up the bags all the way to where they were before. But at first, if you're filling up those bags and they don't pack well at first, and you have to kind of like remove some of the void space that's in there, then you could end up having more. Make it seem like you have more than 3 bags worth. But once you let that settle in and you get closer to that perfect packing fraction, then you definitely should have fall short of filling 3 bags. Okay. Well, that is it for problem number 3.10. Thanks for joining me, and I hope to see you in the next video. Thanks. Bye.